Okay, so this is what we have as a process, and this we can look into this as a simplify or simple crude oil refining process. So that's it. So it comes from crude to desalting, from desalting down to downstream process to purification. Okay, now like as I said, we'll be looking into desalting majorly. We're looking into desalting majorly, but let's consider a process, a flow from the beginning to distillation. So we'll have crude refining flow to distillation column. Okay, so assuming you have crude here, crude oil coming in, it has to go straight into what we term as hen. And what does hen stands for? It stands for heat exchanger network, or heat exchanging network. So what it does is to change the heat content of the crude that is coming in by increasing it. Remember what we said at distillation, it is all about boiling to vapor. So as a result of that, the temperature has to increase from the point where it was brought in to that particular level where it can separate into the various fractions. So after that, we can come down straight to removing any kind of salt or suspension that is present in that particular crude, which we called the salts or desalting. And what you use as a device to do this particular to suit this particular purpose is called desalter. So it's desalter remove water, remove suspensions, remove salts. So when I say water, I mean water that contains salts. Okay, after that it goes through another heat exchanger, another N. From there it goes straight to a funnel. Don't mind my diagram, but this is actually what a funnel looks like. Okay, so here is a funnel, and the function of the funnel, also one of the function is to heat up that particular crude oil. So you see the temperature actually it's not increasing mainly from at the distillation column, but built up from the beginning of the process. So the last, as we said, to distillation column, it's if this is what distillation stands for. So we have here as distillation column. So we will stop this flow at this particular point, knowing carefully that at the distillation column, what we do is separating it into various fractions using their boiling points. I repeat again, at distillation column, what we do is separate the various fractions of this crude into fractions, different components, using their boiling points. So, like as I said, today we'll be looking into desalting, which is a process that will happen at the desalter. So from here, we can say that we get sour water out. Sour water. So is either you term it as sour water, salty water, or still the same? Or still the same. Okay, so let's look. Let's look into the desalting. Desalting, by definition, it's actually a process now. Like as I was saying, desalting is actually a process of removing dissolved salts out of the crude oil. So since it is a process of removing dissolved salts from the crude oil in order to avoid corrosion, fouling, and etc., we can term a desalter as a separating process. So another definition is we can look into it as desalting is a separating process which results to removal of dissolved salts, removal of water, caustic chemical, any acid present in that particular crude oil, and also a process to reduce performance of catalysts by the salt is being enhanced by this particular desalting process. So lastly, we can say desalter, it actually remove salt, dissolved salts. So let's look into what the process, a desalting process. Let's look into a desalting process. Okay, let's say here we have crude. Crude or desalting. Desalting process. Desalting process. So if that is our topic. Now let's say this is actually a pump which receives a crude oil. It receives crude oil. Then after that, it receives it. It's supposed to take it straight to what we term as a missing valve, which is more or less like a globing valve. Globing valve. And lastly, we look into the desalter. Desalter. So this is a desalter. So here there are various types of desalter. There are settling type, there are electrostatic type, and we have gravity type. So there are various types of desalter, but we'll be concentrating on electrostatic type of desalter. And the reason why that is one of the best, or the best rather, is because it enhances performance, it enables you to save costs. So number one, it boosts the performance of whatever you get out of the crude oil in terms of separation. It gives you the best. It enhances that particular, it gives you speed, it gives you time, it helps you save time, it helps you save costs. So we'll be using electrostatic separator or desalter. Remember what I said? I said a desalter is a separator, which is a desalting process is a separating process. We have to understand that. Okay, now this is what we have. But before this whole process began, there are other things that we have to do, and one of the things is to look into this. We have to demulsify the crude. So we add demulsifier agent, and we'll be looking into what these agents do later in future. So I call this a missing valve. A missing valve, and here you have two things coming out as a product. Number one here is what we called effluents. Remember we said in one of our previous lecture, we said anything that comes out of a fractional distillation, we call it a name, but here we look into it is called effluent water, which is the water that we don't want, the salty water that we don't want in that particular crude oil. Now here we have desalted crude oil. So what we're looking into here is that when you bring in a crude oil into a pump, before it gets to the desalter, you have to first of all add a demulsifier agent to it. And this particular demulsifier, what it does is actually to remove any carryover water. That is one of the things it does. And after that, you pass it into the missing valve, which we called globe valve. And the essence of this particular missing valve or globe valve is actually to reduce the pressure coming in after the pump here, before it gets to the electrostatic separator. Okay, so at this particular level, it is assumed what happened here at the electrostatic separator is that here the crude oil and the water is being separated. Not just the water, the effluent water, it's salty water. Let's use the word salty water. So the salty water comes out at the bottom, and the crude oil, the desalted crude oil, which is more or less like is a crude oil without or with little, say 0.2 salt, comes out at the top. So that is what happened at this particular desalter. That's what happened at the desalter. And if, for instance, that the amounts of salt we have here is still much, and you still have to desalt it, you now go through another process. So the whole of this is called the first stage desalting. And if it goes to another desalter again, we call it second stage desalting. Second stage desalting. And that particular diagram, you can see it. It's in your handout if you go to that. Okay, so if for the desalting process is needed, the actual thing that you need to do at this particular point is to add another quantity of fresh water to this particular product you are getting, the desalted crude oil, and after that you pass it through another mixing valve before it gets to a desalter again. So you see, it's just like the only thing outside the first stage or the first stage desalting is this particular pump here. So this and this has to come in again, and you can go further with that in our handout. Okay, now, like as I was saying, I said there are various types of salts present in crude oil. Number one, we have the sodium chloride salt, which is NaCl. Then we also have magnesium type. We have other impurities like clay, impurities like clay. We have iron sulfide present in crude. We have vanadium also present. We have nickel also present. So all of this is present in the crude, which has to be removed, especially this, or the sodium, the magnesium type, which must be removed at the desalter. So at the desalter, the goal is that we have to reduce the salt level to about to less than 0.2 volume being present. So at that particular level, we should be thinking about a good process without salts. Now, furthermore, there are other salts present, like calcium chloride. We also have, as I said, magnesium chloride also present. So all of this needs to be removed, and that is taken care of by, especially the salt, taken care of by the desalter. So that is what we have. So in essence, we can call desalting. Desalting involves, we can define it as a process which involves mixing heated crude oil with washing water, then pass it to a separating vessel here, which is a desalter, in order to produce a desalted crude oil, which is almost ready to be used at or sent to the distillation column, as we said. Okay, so desalting, we now know what it does. So in summary, is that a desalter a desalter remove 85 to 95% inorganic salts that we can also refer to as water soluble salts. And not only that, it reduced the water. A desalter remove the water in the crude what we term as emulsion to less than 0.2%, so that when it gets to furnace, it can easily vaporize before going to the distillation column. So that is what a desalter does. We said a desalter removes 85 to 95% inorganic salt. And not only that, it removes the water present in that particular crude to less than 0.2%. So this is definitely where we are going to stop today. But before we finally go, we'll look into how does this desalter separates the crude, desalted crude, and the effluent water. That will be our next area of concentration.
Thank you.